Hey everyone, welcome back to yet another problem of the day. Let's solve today's LeetCode daily challenge. The problem is minimum falling path sum. The given an n cross n array of integers matrix, return the minimum sum of any falling path through matrix. What does that falling path means? Is the falling path starts at any element in the first row and chooses the element in the next row, that is either directly below or diagonally left or right. So specifically the next element from position row or column will be now let us try to go here right here. The the next move from row call is nothing but one move row plus 1 and call minus 1, and this is one move. The other move is row plus 1 and call, and the third move that can be is diagonally right, which is row plus 1 and call plus 1. So these are the three moves that can be moved from one particular point. What that is nothing but from this two we can move either either we can move from diagonally left but it is out of boundary, or directly below, which is 6, or diagonally right, which is to 5. If I am standing at this position, I can move either to 6 or 5 or 4. If I am standing at this position 4, I can move to 8 or 9 or this part, but this is out of boundary case. If I am at this position 5, I can move either to 7 or 8 or 9. These are the three possibilities. So if this is the possibilities, what we have to return is we want to return the minimum sum of any falling path. So we want to calculate the minimum sum that we get in the falling path. So obviously there are n columns, right? This can be a starting position, this can be a starting position, this can be a starting position. From each position we can have a minimum falling path. So what we can do is we can have a for loop for each element in the first row, so that we can start from that particular cell and we can try to reach the last row, yeah, and we can get the minimum optimal answer. So what's the obvious intuitive solution that comes to my mind is the recursion, where we can have a recurrence relation, uh, recurrence relation that is nothing but if I'm having an ij, if I'm having an ij, then dp of ij, the recurrence relation will be exponential. So I can memorize this solution using dp. I can use a memoization technique here. If what does the dp of ij is nothing but the minimum falling path sum till I comma j, till the index I comma j. This is going to be my dp states. So there will be two dimensions. So but here we want to take all the possibilities, that is I want to consider all the cells in the first row. So we can write the code so that we can get a clear understanding what we are doing here. So before that, so actually, I will explain the example as well. There will be a sum here from 1 to 5, then to 7. So what will be the total sum here is 13, and I can have another sum which is 1 to 4 to, and then from 4 to 8, then their sum is also 13. So there are multiple ways, but the 13 is my minimum path sum that I can, minimum falling path sum that I can get. That is the most optimal, and I cannot get more than I cannot get more than minimum than that. So that is why the 13 is our answer for the example one. So here we are trying out all possibilities, so obviously we can go for recursion. So what we can do is we can have a min path sum variable which is going to be initially int max, and I'm at the end of the day I'm going to return this min path sum. So here I want to first take the columns here we can just take matrix dot size, because this is a n cross n matrix only, square matrix. So just a minute. Oh, sorry, we can also have the make use of this timer. We can start the timer. Consider we have already passed 5 minutes. Consider we can have the timer starting from 5 minutes. Okay, now we can have the rows, which is the n, and this is the n cross n matrix, so rows and columns are n. Now what we can do is, so we can have a for loop here. Why this is for loop is, we want to consider everything as starting point. So I equals to 0, I less than n, I plus plus. So I'm going to call one recursive function that is going to return me the minimum falling path sum. Let us say the cur min path sum. This is going to be the recursive function that is starting from this particular cell I. So let us say that function to be get min path sum. So this function is going to return me the min path sum starting from the first row's ith column. So this is nothing but the column. To be more precise, this is nothing but the column. I can have it as call. So my row number will be 0. So we can have 0 as R1 parameter, and column is going to be another parameter. And the next thing that I can pass is matrix I can pass, and even I can pass n as well. And I hope this is enough for this function. And for each time I'm going to update my min path sum. Min path sum is nothing but the minimum of this min path sum and the cur min path sum. So, and at the end of the day I'm going to get the minimum path sum. So now let us write the function that is enough for this problem. So this is going to return an integer, but let us consider this is going to return a long value, because if I'm going to go out of boundary case, I'm going to return an integer int max value, that is a maximum value. So if I add 1 to that maximum value, it is obviously going to return me an integer overflow error. So consider we are going to have a long value that is returned, and we can typecast here as well. It is going to be an integer. Okay, now I'm going to have this data type to be long, and let us say this get min path sum, and this is going to be my row, this is going to be my column, and this is a vector of int numbers and matrix, and even we can have the size, which is nothing but n. So what is our base case? So as you can see that this is the image, right? This is the image, and I'm currently at this position. So I will be either move here or below or diagonally right. Again I will be consider I'm at this position. Either I will be moving to this position, to this position, to this position. Consider we are at this position. So if I'm at this position, what does that mean is my row has reached the size n minus 1. So that is going to be my base case. If my row has reached n, if my row has reached the last cell, last row, if my row has reached the last row is nothing but n minus 1. If this is reached, then we can just return matrix of row call. Before that, we can have another case. What does the another case is? If we are at this position, we will be tend to move to this position, where this is the boundary case. The boundary, it is an out of boundary case. So we can have only one check, which is nothing but if my call is lesser than 0, or if my call is equal to n, then this is an out of boundary case. So we can just return an integer max value. so that I am saying that recursive call to eliminate this path. So this path will not be get accounted. So now we have three options. What are those options? Either directly below, that is down, long down. This is going to be one option. This is nothing but get min path sum, where row will be incremented by 1, call will be incremented by 1, and matrix is called and size n. And what is my other option? Long sorry, call will be remaining same, right? Sorry, so we can go in order. Call will be remaining same. Before going in down, we can try to go as per the question, which is nothing but diagonally left. If I'm at this position, diagonally left, then below, then diagonally right, it will be making sense more. Diagonal left, which is nothing but this same function called row will be incremented by 1, call will be decremented by 1. So if I'm in this position, row will be incremented and call should be decremented. So down will be nothing but row plus 1 and call will be remaining same. So if I am at this position, row will be incremented but call remaining the same. And there will be another case which is nothing but the diagonal right case. Diagonally right move, which will be get minimum path sum, row plus 1 and call will be also incremented. So if I'm at this position, row is incremented and call is also incremented, so I will reach here. So these are the three options I can go. So at the end of the day, I'm going to return the minimum of all the three options. So diagonal left and down and diagonal right. So this is pretty much about the code. So but we have to, each time what we are going to do is we want to calculate the sum. So we can have the matrix of, we can have it in some current cell. Int curval is nothing but the matrix of row call. So each time I am want to make this next recursive call, my curval should be added to my current path. So this should be added in our each move, else we do not get any answer, right? So this is going to be a recursive function. First let us observe whether this recursive code is getting accepted. For example test cases, yeah, it gets accepted. So we want to memorize the solution. This is an exponential solution. We can, let us try to memorize the solution. So what are the changing parameters? The changing parameters are row and call only, that there are the two dimensions are involved. So we can define dp of size. We can define a dp of dimensions 2, which is vector of int dp of size n, and then another vector of int n, initially it is -1. And we can also pass the dp here, and even we can pass dp and a dp here as well. So now we can also we want to have here as well, it is nothing but vector of int ampersand dp. Yeah, great. So now after these base conditions, we want to check whether this subproblem is solved. If my dp of row call is already being solved, that is going to be not -1. So I will just return dp of row call. So superb. Now we can return dp of row call. That's it. Now it is memoized. So the time complexity here will be reduced significantly. Now let us submit the code. So now let us submit our code. Superb, it gets accepted. So hope you like the solution. So let us analyze the time complexity. The time complexity for the recursion is n into, because why it is n? Because there is a loop here running which is going to be n, order of n, and this is going to be 3 cross 3. There will be 3 options for each per cell. I am going to make a 3 options. So it is going to be 3 power n. So for recursion, the time complexity will be n into 3 power n. It is exponential. So if we introduce this DP array, if we memorize the solution, it is not going to be exponential. So this is a order of n, and this is going to be another order of n. So the time complexity will be order of n square for when we introduce memoization. So that's it for this video. And there were that recursion stack space, it will be an order of n. So the space complexity will be an n square and another n for recursion stack space. So that's it for the video. So hope you like this solution, and let me know in the comments if there are any suggestions. Let me know it. So let us see in tomorrow's LeetCode daily challenge. Until then, bye.